The induction motor is perhaps the most common type of electric motor in the world. Induction motors are favoured due to their ruggedness and simplicity. In fact, 90% of industrial motors are induction motors. Who invented the induction motor? Nikola Tesla or Galileo Ferraris? Many sources say that Nikola Tesla and Galileo Ferraris regarding the invention of the induction motor were made entirely independently of each other. Some sources name Nikola Tesla as the inventor of the induction motors based on his filling of US patient 381968, granted on May 1, 1888. Also, Tesla made a commercial success with his induction motor. Many think that Nikola Tesla must share that honour with Ferraris. Induction motors are widely used as industrial drives because they are rugged, reliable and economical. Induction motors have a very simple construction. Construction of induction motor we will explain in this video. The terminal box allows the power cable to be fixed with a cable gland to provide powering of the induction motor. Terminal box consists of screws, terminal box lid, gasket, terminal box case and cable gland. The fan sucks air into the motor, blowing it around the outside of the case past the heat ventilating fins. If you've ever wondered why electric motors have those ridges on the outside, that's the reason. They're cooling the motor down. Fan cover prevents it from being damaged and the fan clamp is holding fan on rotor shaft on right place. A flange is a forged or cast ring of steel designed to connect mechanically sections of a pipe or joined pipe to a pressure vessel, pump, motor, valve or any other piece of equipment. Most used flange types are welding neck, slip-on, socket weld, lap joint, blind and threaded. End shield is part of the motor housing which supports the bearing and acts as a protective guard to the electrical and rotating parts inside the motor. This is frequently called the end bracket or the end bell. Frame is the main motor housing. It can be constructed of aluminium, steel or cast iron, and all motors have a permanent nameplate which lists all important data. Further data is usually available in the motor catalogue. The stator is built up of high-grade alloyed steel laminations to reduce eddy current losses. It has three main parts, namely outer frame, the stator core and a stator winding. Outer frame is the outer body of the motor. Its main function is to support the stator core and to protect inner parts of the machine. The stator core is built of high-grade silicon steel stampings laminations. Its main function is to carry the alternating magnetic field which produces hysteresis and eddy current losses. The stampings are fixed to the stator frame. Each stamping are insulated from the other with a thin varnish layer. The thickness of the stamping usually varies from 0.3 to 0.5 mm. Slots are punched on the inner side of the stampings. The core of the stator carries three-phase windings which are usually supplied from a three-phase supply system. The 6 terminals of the windings, 2 of each phase, are connected in the terminal box of the machine. The stator of the motor is wound for a definite number of poles, depending on the speed of the motor. If the number of poles is greater, the speed of the motor will be less, and if the number of poles is less, then the speed will be high. The rotor is also built of thin laminations of the same material as the stator. The laminated cylindrical core is mounted directly on the shaft. These laminations are slotted on the outer side to receive the conductors. A squirrel cage rotor consists of a laminated cylindrical core. The circular slots at the outer periphery are semi-closed. Each slot contains uninsulated bar conductor of aluminium or copper. At the end of the rotor, the conductors are short-circuited by a heavy ring of copper or aluminium. The rotor slots are usually not parallel to the shaft but are skewed. The skewing of the rotor conductors has the following advantages given below. It reduces humming and provides smooth and noise-free operation. It results in a uniform torque curve for different positions of the rotor. The locking tendency of the rotor is reduced, as the teeth of the rotor and the stator attract each other and lock. It increases the rotor resistance due to the increased length of the rotor bar conductors. Advantages of a squirrel cage rotor. The following advantages of the cage rotor are given below. The cage rotor is cheaper and the construction is robust. The absence of the brushes reduces the risk of sparking. Its maintenance is less, the power factor is higher, and the efficiency of the cage rotor is higher. Thank you for watching this video. Please feel free to support my channel on Patreon or share my videos to social media. Of course, leave a like and subscribe to my channel.